All right, welcome back. In this video, we are going to be going through the guided notes of multiplication properties of exponents. Without further ado, let's begin. So you can multiply a power by what is called expanding each factor. So for example, if we wanted to simplify 4 to the third times 4 to the fifth, then we can technically rewrite it as 4 times 4 times 4. That's 4 to the third, times 4 times 4 times 4 times 4 times 4. That's 4 to the fifth. So we can expand each factor, and now we count the number of those factors. So now we count the number of 4s that we see, and we see 8. So it would be 4 to the 8th. We can definitely do that. So the number of factors, again, is the exponent, right? We can definitely do that, but that's a bit complicated. That's a bit long. We could do by expanding each factor, or we can use the product of powers property. And in the algebraic explanation, a to the m times a to the nth is equal to a, it's the same base, raised to the power of m plus n, so long as a is not 0 and m and n are integers. But let's see this played out in a numerical representation. Let's go back to the same problem on the left-hand side. On the left-hand side, we have 4 to the third times 4 to the fifth. Well, we can use this property here, and we can do 4 times 3 plus 5. They have the same base of 4. Well, 3 plus 5 is 8. And we end up with the same number as we did before, the same answer compared to the expanding form. But let's talk about simplifying a to the fourth times b to the fifth times a to the negative second. Well, we have the same base of a. That appears twice. We have a to the fourth and a to the negative second. So we can add them together. A to the fourth plus negative 2 times b to the fifth. Well, 4 plus negative 2 is a squared. Therefore, it's a squared times b to the fifth. And we can just bring it together without writing out a squared times b to the fifth. We just want a squared b to the fifth. We also can use what is called the power of a power property. Try saying that 5 times fast. I know I can't. And what this means in the algebraic representation is a to the m, if that's inside a set of parentheses, and that whole quantity is getting raised to the nth power. What we can do is we'll have the same base of a raised to the m times n power. So let's go through a couple different examples. On the left-hand side, we're going to be starting with 2 to the third inside a set of parentheses getting squared, getting raised to the power of 2. Well, using the power of a power property, the triple P, we can do 3 times 2. So we have 2 to the 3 times 2, and 3 times 2 is 6. Therefore, we end up with 2 to the 6th power. On the right-hand side, though, we have x to the 5th raised to the 4th power times y. So y is chilling all by itself right now, but no one knows why, because he's chilling all by himself. So we have x to the 5th getting raised to the 4th. We can use the power of a power property, and x to the 5 times 4th power times y. We still tag that y along. We can't do anything with it, but it still gets tagged along. And 5 times 4 is 20. Therefore, we get x to the 20th times y. Awesome job so far, folks. With this in mind, please work on problems 1 through 9 on the guided notes and resume when you're ready to move forward. If you're listening to my voice, that means that you are now on the back side of your guided notes and you want to go over the power of a power property. Well, inside the set of parentheses here, we have 2 different bases. We have a and b, and all of that is getting raised to the nth power. So this is kind of where the distributive property comes in, but we're referring to strictly exponents. So ab, in parentheses, raised to the nth power, that n gets sent into all of the bases. So it turns into a to the nth times b to the nth. Let's go through an example of this. So in this example on the left-hand side of your guided notes, we have in parentheses x cubed, y to the negative fifth, all getting raised to the second. So we're going to pretty much distribute the 2 to all the exponents that we see. So it's going to turn into x to the 3 times 2 power times y to the negative 5 times 2 power, because that 2 was on the outside of our parentheses. Now we're going to simplify. So we get x to the 6th, y to the negative 10th. And now knowing what we know about negative exponents, and we don't want that, we want to be positive, people. We want to be positive. We're going to drop that y into the denominator, turning it into x to the 6th in the numerator divided by y to the 10th in the denominator. Awesome, 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 awesome. Just a quick reminder about exponential expressions and how they are simplified. We know they are going to be simplified if there are no negative exponents, if the same base does not appear more than once in a product or a quotient, aka, do we have multiple x's? Is it x squared times x to the third, or is it just x to the fifth? We only want to have the base written once. We're all about that base, right, Megan Trainer? We don't want to have powers, products, or quotients that are raised to powers, aka we don't want to have x squared getting raised to the third power. We don't want that. So just for a visual, we don't want x squared to the third. That is not simplified, because we can simplify this as x to the 6th. And all fractions have been simplified if possible. Here is a quick diagram for you to look through things that are simplified and things that are not simplified. So we have no negative exponents. The same base does not appear more than once. There's no powers getting raised to a power, and all fractions are simplified. Fantastic job with this so far, kiddos. Please work on problems 10 through 15 on the guided notes. Keep up the great work. Keep making yourself proud. Let me know if you have any questions, and I'll talk to you soon. Have a good one.